Welcome to another session in Database Concepts and Oracle. I'm Manibhushan D'Souza, Assistant Professor in Computer Science Department at Dr. P. Dayananda Pai, P. Satish Pai, GFGC, Mangalore. In the previous classes, we have seen about the different levels of data abstractions. Now let's look at the one other concept, and that concept is schema. So what is the meaning of saying schema? So schema is nothing but the overall design of a database. So when you design a database, you will design its structure. What are the things the database will have, where it will be stored, who is going to access it, and what type of information they require. So you design something. It is identical to the blueprint that a civil engineer will develop when he or she is building a house or a building. So they will design. Suppose if you're building a 2 BHK house, they will design where is the hall, where will be the bedrooms, and where is the kitchen, and so on and so forth. So they will design the overall thing, what will be the length of it, where will be the door, and so on and so forth. In the same way, when we create a database, we have to first design the database. Now this design depends on the various models that you are using. Now if you go to any civil engineer and if you ask them to build a house for you, they will have different models, and based on the models they will give you the different designs. Okay, so if you look at a simple example, suppose if you look at the cars that you have. So these are some of the cars that Maruti has, different models of the Maruti. Now this designs depends on the various models. So we have like Ignis, we have Wagoner, and so on and so forth, Alto, and the other cars. So the design of the car depends on whether you want a hatchback car or whether you want a luxury like a sedan car, or whether you want a SUV type of car. So they all depends on the type of model that you are preferring. And the same way, the schema that you see, that is the overall design, depends on the model which is used for building the database. Now let's come back to the schema itself. So the schema, there are different schema which are available in the database, and this schema depends on the various levels of abstraction that we have in our database. And in the previous classes, we have studied that there are three levels of data abstraction. One is there at the physical level, other one is there at the logical level, and the third one is there at a view level. So depending upon the different levels, there are different designs are there. So at physical level of abstraction, there will be a design that is done at the physical level, and this design is called as physical schema. In the same way, at the logical level of abstraction, we have a design called as logical schema. Similarly, we can have the schema at view level, and you know very well there are different views will be there because different user would like to see the data in different forms. So naturally there will be several views or several designs which will be there at the view level, and these sub schema or these sub designs are called as sub schema. So sub schema is nothing but the sub designs that we have. So let's quickly look at what will be there in the physical schema. We know very well physical level we deal with the how the data is stored and what type of access that the database has. So the design at physical schema will describe the design of the database at a physical level. Okay, And as told in the previous class, you can always change the design at the physical level without get affecting the logical levels. Okay, and this is as told in the previous class, this is called as a physical data independence. Let's look at the schema at a logical level. What we have, this is going to be the design that is required to logically build the or logically use the database. So this will contain the schema that is there at the logical level is called as the logical schema. Generally, as a developer, because if you are developing an application that uses the database, because that is what you are up to. So, being a computer science graduate, you would like to develop the application. So, for us, most important schema or most important design, if you don't like that word schema, most important design is the design at the logical schema, because we would like to know how the things look like, overall things will look like in a simpler format. There is the other level that is called as the sub schema, which are the schema that are used at the view level. And we know that a database will have different views, and the schema that that is being used at different levels is called as the sub schema. Now, I have already told you the schema is nothing but the overall design, and this design, so this is the overall design, is nothing but a schema, and this design, oops, this design is based on the data model. So what is the data model? So a data model is nothing but it's a simple representation of some complex real world data structure. So if you look at the real data, or if you look at the real things, they will appear to be very complicated. So a simple model is being shown. So you know very well, if you look at the house design that is done by an civil engineer, so there will be some rooms and there will be some doors. You don't really get it. You know that there will be a door here that you can enter, there will be door here you can enter, but you can't see the, you can't visualize how the things will look like. So what they will do is they will build a model for you, and they are going to say your house will look like this, there is a door here, and so on. So you get some visual representation of how that complex structure will appear in real life. So that is what is the model. So it's a simple representation of some complex real world data structure. Okay, in our case, it is the simple representation of the database. So we are looking at the underlying structure of the database in the data model. So how the structure, or what is the structure of the database, is represented by a data model. So what is there in a data model? A data model consists of conceptual tools that will describe what data will be stored in the database, and what are the relationship between the various data items that are being stored. For example, when you store the details of a student, so his name or his mark and so on and so forth, along with the marks that are stored by the student, maybe in various examination. Now, this particular model will describe how the data is stored. So, what are the different items which are stored, and how one thing is connected to the other thing. What is the way in which the connection is established, and that is what is called as the relationship. So, relationship between the various data item, as well as the meaning, that is nothing but the semantic. Also, what are the data that you can have? Can you have any data at any place? For example, if you have marks of a student, then can I have -5 as the marks of a student? So naturally that is not allowed. You are not allowed to have a negative numbers for marks. You can have 0 in a particular subject, but you can't have negative marks in a particular subject. So this is called as consistency. So that the data will be consistent throughout. You know that the you don't have a bad data in a particular field. Okay. So in summary, a data model provides a way to describe the design of a database at different levels. And you know very well, design of the database is called as a schema. That is what I told you. And when I explained about the schema, I've already told you a schema is nothing but a design. And the design is based on the model. So what does the model will do? Model will describe that design. So when you have the design, how the things will look like at various level, like physical level, logical level, and view level, how the things are stored, how the data is stored, how one thing is getting connected to the other thing. There are different ways in which you can do it, and that is what is described by the data model. So don't get confused. Schema is the design, and the way in which this design is achieved by a model that describes this data. Now it will be very easy if I explain about various types of models, then you will be able to connect the model with the schema. So now let's do that thing. Okay. So a model is nothing but a logical structure that tells what is the manner in which the data is stored and organized as well as manipulated. So there are different ways in which the data can be stored in the database. One, you are very familiar, in a particular tabular format you can store the data. So most of you have used Microsoft Excel to store the data. So if you are storing your data in a tabular form, this is one model that you are using. There are other type of models that are available. So if you, because you have all used Microsoft Excel, you know how the data can be stored and how you can manipulate it, how it is organized. There are other models that we are going to see very soon that tells the different other ways in which the data can be organized. So what is there in a data model? So data model is nothing but it's a collection of high level data description constructs, and it is used to hide the low level details. So what do I mean by saying that is, if I say that I have stored the student marks like 50, 70, and maybe 81 and something, I have stored some student mark here. Now this is the logical way. Now how it is physically stored? Physically it may be stored in the forms of zeros and ones, because you know very well computer understands the binary. Now it is not binary alone, it may be 2's complement form. Hope everybody is familiar with that 2's complement form. So some format, some complex way in which it is being stored. Now, this model, if I say that the data is stored in a tabular form, this is a simpler view of the complicated real storage. So that is what is the meaning of it. So a data model is a collection of high level data description. This is at the high level. What is the meaning of saying high level is it is simpler way. So I hope everybody is familiar with this idea. You have studied in programming language, you have high level language and you have low level language. So which one is tougher? So is the high level language is tougher, or is the low level language tougher? The answer is the low level language. Why low level language? Low level languages are machine language or assembly language, which are difficult Whereas high level language is your C, C++, Java, and all of them are high level language, which is easier because they are more like English like syntaxes. Whereas here you may have to use mnemonics or some other maybe binary direct format itself to write the program. So this is the low level that we are talking about is usually complicated, whereas the high level is simple. Even though the word high means you may think that this is complicated. No, that is simple. High means it is closer to you. Low means it is closer to the hardware. So that is a simple an analogy you can take it. So a data model is a collection of high level data description. What is the meaning of it is it's a simpler format of data description which hides all the complicated low level details about the storage. Okay. So when we use a database management system, like Oracle or any other database management system, they help us to define which data that we can store and how it can be stored in terms of a data model. Okay, so now let's look at different types of data models. Generally, there are four types of data models are there. One is called as relational model. Second one is the entity relational model. Third one is the object based model, and the third one is the semi-structured model. Let's look at individual model. That is what I told you. Remember, let's again, I want to confuse you one more time. So schema is nothing but the overall design, and this design is based on the model. So this design is described by a model. So that is what we are looking at now, and we are studying the different types of models. So let's study the first type of model. Remember, model describes the data. It says how the data is arranged. So let's start with the first one, that is the relational model. So relational model is based on the concept of a table. So table is nothing but a two-dimensional representation of data. You have used this table in Microsoft Word, or when you created a timetable, you have used the table. So what is there in a table? Table contains rows and column. Now that is the design. Hope you got the idea. So this schema, what is schema? Schema is the design. So what is the design? It is a two-dimensional arrangement. This is the design. And how did I get this design? This design is based on the relational model. Hope you got it. Okay. So you have a design which is a two-dimensional arrangement of items, and this design is based on relational model. Okay. Why it is a relational model? I will explain it uh, very soon. So let's look at this tabular structure. So a table consists of columns, okay, that describes the attribute. So in other words, that describes the property or that describes the characteristic of something. For example, a register number for a student, register number is one attribute that describes the student. So I can identify a student by his or her register number. So it becomes one of the attribute that I can use or I can associate with the student. A student also has a name. This is also a attribute. Because he or she is a student, he or she should have studied or is studying in one of the course. So that is again one attribute. We call somebody as student because they have joined for one of the course. So what is this register number, this one column that you see here? This one column is nothing but an attribute that describes the one characteristic or one particular attribute, one particular property of a given item. So all the items over here that you see have the same attribute. So in other words, you take any row here, all of them have the same attribute. What do I mean by that? Again, I know you got confused with that. So let me write 101. Okay, I'll put a comma now just to make, because to draw a table I will have to uh, put more effort. Okay, I will write Mangalore. You know what is Mangalore? And Manish and BC. Now I write 102. You just imagine what is happening. Rashmi, okay, BC. Now you notice the strange thing. Both of them are not identical. Why both of them are not identical? There is Mangalore which is missing in the second. Is the second part here, this is missing. So that means they are not identical. Whereas if you look at here, every one has register number, everyone has a row, everyone has joined a course. So this is fixed. So this structure is a fixed structure. It is not a flexible structure. You can't change it. If you change it at one place, you have to change it at all the places, so that every one will look alike. Hope you get the idea there. So now let's take one particular row here. So this one particular row is called as either a record, it is also called as a record, or a row definitely, or a tuple or tuple. So there are two pronunciation for that. Some people call it as tuple. I call it as tuple. Somebody else may call it as tuple. Okay, so it depends on who is making the pronunciation. So in order to satisfy both of those pronunciation, I will sometime use the word tuple. As of now, I am going to use the word tuple. So it is called as a record or a tuple. Okay, so let's recall what I have told you. One particular column is called as an attribute. It is also called as a field. One particular row is called as a record or a row or a tuple. Okay. Every column has a name that is called as a field name or column name that uniquely identifies one of the characteristic of a given item. Okay. Generally, all the tables will have a name associated with them. So this is the idea of a relation. So this whole table that you are calling, so you call in a general language, you call it as a table, but to confuse you, we call it as a relation. Okay, so it is not a table, it is a relation. So what you see here is a relation which consists of number of tuples. Okay, every tuple has a particular attribute or a field. So now, how do you build the relationship? I told you the model describes the data. So this is how the data is being stored or represented, and also it shows the relationship between the data. So where is the relationship? How can I build the relationship? So something is missing here. So let's assume that this was supposed to be subject. I think that went out. So you have a table called students table and you have a subject table. So students are there, okay, with the student ID and some age, and we have the subjects with the subject ID. Subject ID is nothing but your paper number, and the subject name. and who is teaching that particular subject. So you have that thing. Now these again, I think I removed that subject. So this is the subject table. So now student is related to a subject. How student is related to a subject is because a student is studying one of the subject. How do I do that thing? Again, recall that the data is represented in the form of a relation. What is a relation? Relation is the other word for a table. So data is represented in a tabular form. Data is also represented in a tabular form. Now I want to connect one table with the other table. So the data which is there in this particular table, I want to connect it with the data that is there in the other table. How do I do that thing? To do that thing, again that subject went off, so I'll just put that subject. So to connect the student relation with the subject relation, I create one more table or one more relation that gets the field is nothing but an attribute. So the attribute of the students table as well as the attribute of the subject table. Apart from that, it can have some other details. Now what is happening here? Student id 1 has taken the subject Java, and he or she has the marks 98. Again, student 1 has taken the subject 2, which is C++, which is taught by Miss C, and has some marks. Again, student 2 has taken a subject 1, which is Java, which is taught by Mr. J, and he or she has got 76 marks. So you notice that the relationship between the table is also done with the help of a table. Okay, and that is what is the relational model. So let me summarize what is there in the relational model. So relational model uses a collection of tables that represent both the data as well as the relationship among those data. So you are using just table to represent everything. Every table consists of multiple columns, so you are familiar. So I have just shown you a few for the simplicity. So every table has multiple columns and every column has a unique name. Okay, this table is called as the relation. Okay, and there are several records are there, so records are also called as tuples. Okay, so there are several records are there. Every record has a fixed format, so there is fixed number of fields are there. Okay, and this is what every record has a fixed number of fields or attribute, and these attribute corresponds to the column of the relation or the table. This model, relational model, is heavily used in the industry. So this is the one that is most frequently used, a data model, when we talk about the databases. Now let's look at the next model, and the next model is based on the entity relationship model. An entity is nothing but the thing or an object in the real world. The object can be a physical object like your car, bus, book, refrigerator, and anything which you can touch and feel. So that is the one. Or the thing or object could be concept like customer transaction. Now, if you didn't really get it, now all of you have passed your SSLC examination. So the you and also all of you have passed your PUC exam. Now tell me, what is exam? If I tell you that, okay, show me Taj Mahal. So if I tell you show me Taj Mahal, some of you may take me to the Hampankata near the signal light and point at one building and say that that is Taj Mahal. The others, those who have a lot of money, may take me to the Agra and show me one structure and say that that is Taj Mahal. Okay, then you know what is Taj Mahal. Now, I am asking you, you have completed your SSLC, you are saying that you have completed your SSLC, you have completed your PUC. Show me that exam. Where is that exam? Exam is a concept. Remember, you can't see, you can't touch that exam. What you can, if you say, no, I can touch, what you can touch and feel was the marks card that you have. Okay, the result sheet is in the form of a paper that you can touch. You can't touch the SSLC exam, so that is a concept. So let's come back to the subject here. When we say entity, entity could be a physical object which you can touch and feel, like your computer mouse and the keyboard, all that you can touch. The software that you can't touch, which you are writing, that is a concept. Okay, so it could be also a concept. So entity could be a physically existing, or it can be a logically existing one. So you can have an entity which is physically there, or it can be logically there. So you take these entities, which are the items which you can see in real world, or which are the concepts in the real world, and you try to find the relationship between them. Now, usually these relation is shown in the form of a graph that is called as entity relation diagram. So in the form of a diagram that is shown, and that is called as entity relational diagram, or it is also called as ER diagram. Now, before we look into that one, let's look at the entity relational model. So what is entity relation model? So entity relational model consists of entities, okay, which are nothing but real world objects, and the relationship among those objects. Okay, so there may be many things which are there in the real world, but we will not consider all of them. We will consider something that are of interest to us. Okay, for example, you may have a brother or sister. Mangalore University is not interested in their name and their phone number. Mangalore University is interested in the phone number of your parents or guardian, but not your sister and maybe your somebody or your neighbor and others. They are not really interested in that. So in the real world, there may be many objects which are there, but things that are of interest to us, we only represent them in the real world, in the entity relational model. Everything is not required. When I say everything is not required, again, if I take yourself, if I take yourself, not everything about you is required. We don't store all the details. uh, I am very sure you have not given your weight, your height when you joined the Mangalore University. So you know very well, as a person, your weight and height is really required, but that is not stored in any database of Mangalore University. Why? Because we don't consider that. So that is not things that is of no interest to us. What is interest to us is, have you taken up the exam, have you paid the fees, your photograph, and all those details are of interest to us. So understand that when we talk about entity relational model, we only take the entities which are of interest to us, and we try to find the relationship between them. These entity relational model is usually shown in the form of a diagram. Remember, this itself is not, some of you will get confused. This itself is not the entity relational model. This is the diagram that represents, shows that model. So in this, what we do is we represent all the entities like student and books. Okay, from the student, we take different attributes of a student. Attributes are nothing but the characteristic of a student. Every student has one characteristic, that is their register number or roll number. their name, their phone number, their address. Now you may be wondering why there are two lines, two circles are there, why there is only dashed lines are there for this oval. I will explain about entity relational model somewhere else. At that time, you will come to know why such a thing has been done. But you have an entity called as student, which has lot of attributes. Okay, and these attributes are shown in the form of a owl connected to it. This entity is connected to one more entity called as student. So this entity student is connected to the other entity called as book, which is characterized by the book name, the authors, which has the book ISBN number, the price, and so on. These are all the properties or the characteristic or the attributes of the books. So what is the relationship? A student reads the relationship. So this is the relationship. You can also have something called as cardinality. We will see that thing when we really look into the model. This is general description of this particular model. So this model is the entity relationship model. Let's go to the next model that we have. Now we have seen the two model. I am going to confuse you by taking you to the place from where I started. So where did I started? I started with the schema. So again, schema is the overall design. Okay, this design is based on a model. And what are the models that you have just seen? One is the relational model. Other model is the entity relational model. Hope you get the idea. So the design is based on the model. So again, come back to the car example that I gave you. So the design is based on the model that you are using. Hope the same idea is used here. Schema is the overall design, and this design is based on the model. And just now you have seen two models. One is the relational model and the other one is the entity relational model. Hope you get now that confusion is cleared. So you have the schema, which is the design, and that design is based on the model. And two models you have already seen. One is the oops, one is the where did that thing go? Okay, one is the there is that relational model, other one is the entity relational model, and the third one is the object oriented data model. Okay, so I hope you have studied the C++ programming language, which was based on the object-oriented concept. So, oops, that you have hope you studied object-oriented programming system. So, this idea, hope everybody has studied that. So, this model is based on the same concept of object-oriented design, wherein we see the various real-life objects which are there on world, and we isolate one from the other. Okay. Now, when I say object, there are a few things you are already familiar. So, object, you've seen that thing, encapsulates. Hope you recall that encapsulates something. Okay, encapsulation is there. Hope everybody is familiar with that. If not, other thing. So, object stores the data as well as the related functions. Hope everybody is familiar with that. So this model that you see with the object oriented data model is it is kind of an extension of the entity relationship model by considering the entity as an object. An object can have a few properties, like one of them is the encapsulation of methods, and every object is identified by one property, that is object ID, as well as we have one important concept that we have studied in the object oriented programming, and that is the concept of inheritance. And you may say that no sir, we have also studied polymorphism. Well and good, I agree with you, the polymorphism is also there, but as of now I am only interested in the inheritance. What is the meaning of saying inheritance? So if you look at a car, so car is nothing but a car is derived from a vehicle. Okay, you know very well. Okay, and what is this vehicle? Vehicles are different types of vehicles are there. Some vehicles are they work on land, the others on air, the third one is on water. So you see, a car is a vehicle as well as a car is a land moving or a land transportation uh, entity or a unit. Okay, so similarly, if you take a where is that? If you take a student, so let's say you take let me put it somewhere. Okay, I will escape this one and I'll put it here. If you look at a student, so student means general. So there are different types of students are there. There are students who are going to college. Okay, there are students who are studying in high school. Okay, high school student. There are students who are doing PhD and other. They are called as research scholars. Okay, so we have variety of student. So college student is also a student, is derived from the student. Okay, who is a student? Student is a person. Who is a person? Person, if you take the concept, general concept, person must be a homo sapiens. This is the idea that we have. If you take it to biology, they call us as homo sapiens. So this is the idea. Same again, you may have different types of employees in an organization. So you have an employee. Okay. Manager is also an employee, no doubt. A clerk is also an employee. Okay. Why both of them are employees? Because they get salary at the end of the month. But some things the manager has may not be there with the clerk, but all the properties of the employees will be there both with the manager as well as clerk. This idea is called as inheritance. And in object oriented programming, this concept is heavily being used. So this model that you see over here is an extension of entity relational model with the for the object oriented data model. Now we have to understand one important thing. This object oriented model is actually derived, or it is a sub model of object based model. So the bigger model that we have is the object model, in which you have the entity relationship data model. Object model is there, semantic model is there, and functional models are there. These are all derived from, or these are all the sub section or sub models of object based data models. We will not look at the semantic model and functional model in this course as of now. Let us look at the other type of model that we can use, and that other type of model is called as semi-structured data model. So semi-structured, you know very well, it is not completely structured. The previous models that you see are all completely structured. If you look at this particular table, it is completely structured. I've already told you there are, everybody has the same number of fields, and the field may have the same data type also. I hope everybody is familiar with the data type like int, float, character, string, and so on and so forth. So the size of every record is fixed with the fixed number of fields. Whereas when we talk about the semi-structured model, now here the model may not have the same structure. Now usually this model is represented, one of the way in which you can represent this model is in the form of an XML, which stands for extensible markup language. Now this is how it looks like. An XML will look like. So you are writing, however, if you have studied this HTML, that is hypertext markup language, it looks like HTML. So one whole thing is called as an node. This whole thing is called as a node. Inside this, you can have sub nodes. Inside this, you can also have the other nodes. Okay, for example, I can represent you as all of you as students. Inside this, I can have student. There is a collection of student, and I am representing one student, and one student has a name. Okay, and the name is I'm going to say XYZ. Okay, you can't get any good name. So this is name. Okay, then I have roll number. Okay, roll number 1, 2, 3, and so on. A roll number. Okay, so you have that, and I'm going to close that. Oops, student. Okay, you notice here. Let me change the color, and if you notice here, this is one node. Okay, there are two attributes are there that which are part of the student. One is student has a name and roll number. I can create one more student. I'm going to create one more student again. So to create a student, I start with the student. Okay, then I am going to say roll number. Okay, 143 slash roll, oops, slash roll number. Okay, and then slash address. I'm doing it purposely. Okay, and you may say that, okay, where is the name of this student? Oops, Mangalore. Okay, and address. Oops, not as address. Okay, so that, okay. Then I have slash student. Okay, and finally I'm going to close it a bit here with one more thing. Okay, I'll slightly write it here with maybe red color. That will be useful. Students. So few things you will notice here. One is, to start you use some key written in angled bracket. Okay, to close it you use the slash. So this is the opening and this is the closing, and the word should be same. Again, this is the opening part, this is the closing part. So this one thing represent a node. This thing that you write in between the opening and closing, if you notice that it is opening and this is closing, and closing also always gets the slash. So the number that is written or something that is written in between them are the values. So name of the student is XYZ, roll number is 123. Now you will notice a very strange thing here. I don't have a name in the other one. Just compare it with the table. If you're doing it in a table, then if you put a name here as first column, all of them must get the name. You can't get the roll number here. You notice here, first one has the name, second one has in the same column, if you take, second one has the roll number, which are not identical. That is why I told you that when you create a table, the structure of the table is fixed or rigid. You can't change it. Whereas here, the structure can be changed according to our requirement. So, and the structure is not fixed. That is why we say that this is a semi-structured. Hope you get the idea. So, this is a semi-structured model. Everybody, you got this particular idea of this. And you will notice one other thing, one strange thing about it is, there is no separation between the schema, that is the design. So this is the design. You start with the root, You start with the result. This is the actual data is here. Get here. Actual data and everything is together. It is put together. So there is no separation between the data as well as the structure. Schema is that design. Okay, you don't get the two things. Okay, and this structure depends on the purpose where you are using. So it is not a rigid structure. This particular design is not rigid. You can change it. So that is what is the semi-structured data model. So semi-structured data model is a model that permits the specification, that is how the data has to be represented, okay, of the data, wherein you can have the individual data type, okay, may have different set of attributes. I've just shown you. So there was a, like, address was there in other place, in the previous example that I've shown you. I've typed and shown you. You had a roll number, but instead of roll number something else came. Okay, so you can have different attributes. Okay, as compared to the previous data model, like your the entity relational or object model. Okay, you don't have a rigid structure there. So every data item of a particular type can have different things. This is in contrast with the previous one, wherein every data type must have the same attribute, whereas that is not required in the semi-structured model. And if you study this idea of a semi-structured model, so I don't know whether you are familiar with the idea of sentiment analysis. There is something called a sentimental analysis, wherein people try to see, when you write the post in the Facebook or any other, people will try to, usually when people write a review on a particular item. So if you go to the Amazon and look at the item, or if you try to buy a mobile, you will see the comments that are written by the different user. And by reading that, you will be able to understand whether to buy that product or not. So as a manufacturer of the phone, you must know what is the sentiment of the customer, whether are they happy with it or are they not happy with it. So how do they do that thing? Is to, they have to go to the Amazon, they have to go to Facebook, they have to go to the Flipkart, find out what is the comments that are given by the different customer. Now to do this, it's going to be manually. If you try to do it, it's going to be a horrible process. So we use the machine to process that sentiment, and there is a lot of research that is also going on in this particular area, that is sentiment analysis. Okay, that idea, if you really want to do it, you complete your MSc and then join for a PhD or MPhil. I think MPhil is now out, so you can do PhD on that also. So more about it in the real classes. I will not spend my I will not waste your data pack by telling you something which is irrelevant as of now. Okay, so let's go with the next model. And there are two other models. Remember, if again I'm going to take you back, or maybe some of you are angry with this kind of switching back and forth. When I started with the data models, and I just told you that there are four models are there. Okay, so relational model, entity model, object based model, and semi-structured model. Now what I am trying to say is there are other models which are there. One is the hierarchical model and the network model. These were the old models which were there. More about it in the next class. I'm doing it because sometime a question can come in your examination: explain the hierarchical data model or explain the other data models. Okay, thank you for your interest. We will meet again in the other class. Thank you.